If you have any kind of a question on the book contents, that's fine. But since, like I said, most of the quiz questions are coming from the knowledge exercises, we cannot really talk about specifically a specific solution for the actual knowledge exercises. But anything in the book, anything from the occult perspective comes up, make sure that you guys use the discussion board for those kind of questions. Now, the other thing that would be also helpful is if you have a question, a concept that it doesn't make sense to you, it would be nice to have the question on the discussion board before the live meeting, before we're going to schedule another live meeting or something like that, okay? Because that way you guys would give me some time to prepare maybe a better presentation than just having the question on a more complex concept in this chapter. So it's the course is not going to be as simple as the first intro level C++ or Java courses were. So the concepts are a little bit more involved. So giving me a heads up on what does make or what does not make sense within the chapter would allow me to give you a much better presentation if we have to have a presentation on a particular concept. Okay? So if something comes up, jump right there to the discussion board and type in your concerns. Okay? Now, like I said, if some of you know the answer, you guys can answer it. If not, then I can bring it in live sessions. If you don't have the book, you're going to be so frustrated and you're going to be pretty much lost. There is no way around that these concepts are not about code anymore. Okay? So Googling something doesn't really help you because we're not here to really talk about the syntax anymore. Okay? But all the chapter questions or the quiz question and test questions are going to require the book, and you have to work on those chapters. And that's why right now, the first couple of days, this is a very fast-moving course, so we cannot really hesitate. If you don't have a book, you're already probably 3 chapters behind. Because by the time you get the book, you already covered 3 chapters. And you probably have, by that time, low quiz grades. But it's going to be very important that you do have the book, you kind of prepare yourself for a course like this, because you don't have 4 weeks to cover a chapter, not like or 2 weeks to cover a chapter, like in major semesters. Okay? Summer, not just summer, but summer 2 is so short. You have to work every single day and read ahead as much as you can in order to really get through these courses. It's not just because of the reference in the chapter, like Ivan is saying, it's because really the concept is explained in the chapter. So it's not just, what is the assignment, why am I just saying, assignment 35 on page 55. And you say, well, that's the only reason I need the book. No, not really. A lot of these concepts, which we talk about in these chapters, are well explained. I really like the book, and talk to each other. Okay, I would really recommend that you guys do talk to each other about this. But I think you can save yourself a lot of headache and a lot of hardship by getting the book and really in one in one place, you will get all the answers that you need for this course. Instead of watching a bunch of YouTube videos for 5 hours, Googling for 2 hours, you already spent 7 hours and you don't know if you're on the right track. If you spend 2 hours per chapter, I guarantee you're going to understand that concept. Okay, so yeah, I cannot really force you to get the book, but I will. If you want to learn this concept, I would recommend it. Okay, I did not write the book. I do not get any kind of breaks from the publisher or the author or anything like that. Our college does not get any kind of kickbacks. So don't think about it like this is some kind of a conspiracy that or somebody wants to force you to pay more. No, it's really, this is one of such an important courses in your career as a programmer that you don't want to skip that. Because it's not about just getting the grade. Okay. But that would be my input into that question, I guess. But like I said, talk to each other, because others probably read the book or read a couple of chapters, and they can tell you how much easier it is to go through the review questions. And some of you already tried the review questions, okay? And I think that's a good measure on what is in the book, in the chapter, and if you understand the concept or not. Because many of you are programmers, okay? Or you programmed before, or you feel really comfortable about Java. But maybe you didn't really look at it from that point of view. What we're going to be talking about in this class, which is data structures, and what's the difference between different implementations of different algorithms. And that's what you want to know. Okay, so this is not about syntax. Okay, it's not just about intro level Java. Yeah, I don't like the actual sharing. You see, here we have, when you are inserting something or fetching something, or you are updating an array. I mean, those are all done the exact same way. Okay, so here this code sharing is really not the biggest issue here, because all these are methods that are written already. So it's most of this code going to be in the book itself. But how do you implement them? How do you implement them so your code is going to be the fastest? Okay. So then the main thing is when somebody says, let's do a binary search versus a sequential search. Okay. So as far as we are concerned in previous classes, right? You just probably did a sequential search because that is just what we do, right? That's the easiest way of implementing it. But it's still going to be a sequential search. But what do you mean by a sequential search, right? So you have an array, right? And then in the array you have your index values, and then you're looking for something that's at the end of the array. Okay, so now how do you do that? Well, you're going to go to the first value, the second, third, fourth, fifth, and then eventually you locate that value. Right? So in that case, if this array grows, okay, it doesn't matter how big it grows, your performance, the big old performance is going to be n. Okay? So if you have 200,000 values in an array, it's going to take 200,000 iterations to get to that number. So this is really slow, right? Now, what if somebody implements this in binary search? So what do we do in binary search, right? So you have your array, okay, and then within that array, you're looking for, let's say, a value, right? Now this is already sorted, right? So this is sorted, and then what we do in the first iteration, you're going to go to the middle of it, right? And because it is sorted, you can figure out what you're looking for, and then figure out that the value I'm looking for is in this half of the array. So that means we just threw away half of the array, right? And when you further search, then you throw another half of the array away. So that means every time when you are searching for a value, in each iteration, you're turning or throwing half of the array away. Okay? So what does that mean? In this particular case, we only need two iterations to get to the value that we need. Okay? So now, when we're talking about the performance, right? A linear performance, more items you have, right? More time it takes. Okay? Versus, okay, so you have your n versus you have the algorithmic, the logarithmic, okay, when you have log 2 of n, right? See, this is the curve. This is the curve that you need. Okay? Most of the algorithms that you're gonna have, as the data grows, they get out of control. Okay? Now you have some of the algorithms that are so bad. See, if you're looking at this chart, right? If I have this particular value n over here, okay? If you look at this chart, okay? If you look at this particular chart, okay, you can see that it might be a really long time before we get to the answer, or we might never get to the answer at all. So thus far, in previous courses, what you guys were looking at is really small data sets. You had an array of 10 items, or 20 items, or 30 items. In this course, we're talking about 1 million, 10 million, 100 million items. How do we handle that? So if you get to that point, right, so far you guys were somewhere here, okay? At this point, it doesn't really matter what algorithm you use, the performance is pretty much the same. Now we are getting to this environment in more resembling real-life problems. Okay? The real-life problems are if the data grows out of hand, how does our implementation perform? So in this case, it is not about the code sharing. It's really not about the code sharing, but really the design of the whole program. And this is when you can make a mistake when you get a code from somebody else or you Google it. Okay? The Googling might refer to, like the intro level courses. In that case, they say, okay, just go ahead and do sequential search. Sequential search gonna get the job done. Yes, it does get the job done in that course, at that level. But now we need to not just look at what the code does, but how efficiently it does it. Okay, so yes, they're going to be not just code sharing, but you can share algorithm. But when you implement it wrong, then you basically get 0 points, because it is not about creating an algorithm. The algorithm is already there, and you're basically copying it from the chapter. But how do you implement it? And that's going to be the biggest challenge. That's why chapter 1 is so crucial, so important. Well, Daniel, to your question, UML is the most important one. Okay, so this is about objects. So UML refers to object-oriented design. So UML has to be submitted for all assignments. But beside the UML, now each method can have either a flowchart or pseudocode. How does it perform the operation? So that's going to be two different things. But there you can pick either one. Okay? So UML definitely, and then beside that, either a flowchart for each of your methods or a pseudocode. Okay? So that's where you need to pick which one works better for you. Okay. So UML plus UML, you can draw it on a piece of just a class diagram. Okay, and you can draw it on a piece of paper, take a picture of it, or use software. I mean, I prefer Dia. Okay, so Dia is a very simple open source tool that you can put on your thumb drive and run it on your thumb drive. Yeah, but just the class diagram of and the relationship between the object, just like we learned it in the previous course, the Java 1 course, right? COSC 2437. So the same kind of UML, and beside that, each method you need to design, and the methods are either flowchart or just simple pseudocode. Yeah, that's fine, but UML generated from source code is okay. The problem is you're doing it backwards. Okay? The problem is that in real program design, okay, the whole idea is you have to design it before you write it. Okay? So when you're saying you want to generate the UML based on the code, that already shows that you don't want to learn this stuff. Okay? You want to do it backwards. Okay? Think about the UML flowchart pseudocode as our communication channel. Okay? If you were an engineer, would you like to have a blueprint before you build something? If you are a contractor, a builder, would you like to have a blueprint to build a house before you start building the house? Or you want to build a house and then draw the blueprint based on that house? Okay? It works either way. It's just what you are generating is garbage. Okay? And that's, for some reason, that's the hardest concept that most people in computer science just does not want to understand, that if you do not design the code, you cannot write the code. Okay? And but unfortunately, I mean, most of you learn to code by writing the code by the syntax, and that's pretty much all the online type of training courses and YouTube videos and all that. That's the side effect of all those bad way of learning things. Okay, but the main thing is you do have to understand how to design the code, because otherwise, I mean, you're not going to be valuable to anybody that way. You're going to be a coder, not a computer scientist. Okay, you're not in a STEM field. Okay, you are a coder who is coding somebody else's design, somebody else's solution. So it depends, you know, what is it you want to be? You want to be an architect, or you want to be the contractor? Right? If you want to be an architect, the most important skill set you can pick up is to design your code before you code it. Okay? But you know, as far as this course is concerned, I'm really not concerned about this. It does take a few semesters, a few courses before somebody starts understanding how important that is. And I'm not going to hold that against you guys. So if you want to generate the UML based on the code itself, you know, the main thing is don't tell me that you did it that way. Okay, so that's the best advice I can say. But yes, design is very important. Okay. Especially in this class when most of the code is basically given. You just have to put them together the right way so we have a better performing code. Okay, any other questions? Because I promise it's only going to be about an hour. So, so at least you guys kind of understand the software, understand the capability, what we can do with this. So we can actually have a decent conversation and a good presentation of each one of the chapters if you use this. Now, if it's annoying or it doesn't work out, and I'm not going to force you to come to live sessions all the time. Okay, so we're going to have a live session tomorrow, same time, and after tomorrow, and then you guys work on, you know, whatever you need to work on for the assignments for the rest of the week, and then next week or over the weekend just post some messages, and then I can figure out if you guys like this way of lecturing, or you guys can just do it, most of this stuff on your own. And you know, in that case, you guys can be on just autopilot and only ask questions when something doesn't make sense. Okay. So yes, this week we're going to have live meetings. So tomorrow we're going to cover chapter 1. After tomorrow we'll cover chapter 2. And in a live session, and after that we'll go by whatever you guys feel like. But chapter 1 and chapter 2 is very crucial. Most people that are good at coding, they're not really good at what's in chapter 1 and chapter 2. So those are really crucial concepts. Okay. Otherwise, if there's no more questions, then I'll see you guys tomorrow. Make sure to read the chapters, do the review exercises, the review quizzes, read the PowerPoint presentations. Keep working, okay? This course is very fast, so don't hesitate with anything, okay? Make sure you have the book and make sure that you communicate on discussion board, okay? So you guys can stay and talk to each other. I think you guys can also get into private sessions if you guys want to do any kind of a subgroups. But that's all I wanted to talk about today. Okay, so hopefully it's going to be a good start to the semester, and hopefully you guys are going to enjoy all this new knowledge within this book. I really believe this is a really good book explaining this concept. And have a great semester, and let's get going, okay? So I jump out, but you guys can stay and talk to each other. Okay?